Assalamualaikum. Good morning to examiner and my fellow acquaintance. My name is Muhammad Daniel B.M NASIR from FTKMP. B0919100022 is my matric number. My supervisor is in chief Fabian B. Idwal. In this slide, I will explain about my project, which is finite element modeling study on the delamination behavior of composite material. There are three contents of the slide, which is introduction, literature review, and methodology. Introduction. In introduction, we have background study, problem statement, research objective, and scope of research. Background study. Composite materials. The term composite refers to something that is made up of several pieces. In practice, the word composite material refers to a substance that is made up of two or more materials with different measures and complementary qualities, resulting in a material with better properties to its original constituent. Second is composite laminate. A composite laminate is an assemblage of a layer of fiber composite materials that may be bonded to offer needed technical features. Woven fabric composite laminate feature a reducing manufacturing cost, increased durability, strong resilience to longitudinal rupture, and crack due very high impact toughness and resilience to threading when compared to their unidirectional equivalent. Delamination. Delamination are one of the most prevalent problems in multi-layer composite material. They can be caused by manufacturing flaws or by operating impact such as heat, loading, impact loads, fatigue, and among others. Once started, they gradually expand with the material with continued loading, eventually leading to component failure. Problem statement. Laminate orientation. When more key elements such as stacking sequence and fiber orientation angle are introduced to multi-layer composite, the difficulty of failure prediction rises when additional essential elements such as stacking sequence and fiber orientation angle are introduced to multi-layer composite. Study to better understand composite behavior make it a requirement to predict and modify damage cycle in multi-layer composite. Second, fracture. Fracture tests are commonly performed to assess a material fracture modulus or toughness. Prepared laminates have been put under fracture test because of the complexity brought on by homogeneity and asymmetry. The technical characteristic of composite material is still an origin of uncertainty. Mechanical property. Mechanical properties are the physical characteristics that material show when forces are applied to it. The vulnerable elasticity, tensile strength, elongation, hardness, and fatigue limits are examples of mechanical qualities. Research objective. Objective 1 is to identify the total deformation of the composite material. Objective 2 is to model and simulate 3 bending fracture testing by using ancient composite breakpoints. Objective 3 is to evaluate the benchmark of total deformation between the simulation and the theoretical data of balanced symmetry layout, quasi-isotropic layout, and unidirectional layout of epoxy carbon woven prepreg. Scope of research. Scope 1. The simulation will be run using ANSYS composite prepreg software. Scope 2. The laminate each will be tested for 3-point flexural bending test on 100 N to 800 N. Scope 3. Three different forms of symmetric orthotropic composite laminate are investigated with the following configuration: balanced, quasi-isotropic laminate, and unidirectional laminates. Next is literature review. Explanation of the theoretical aspect of the experiment research. Composite laminates. Balanced symmetry laminate. A balanced laminate is explained that one for every plus degree ply in the layout there is an equivalent negative degree ply in the layout. The symmetric laminate is one that is balanced along its midline and has a mirror image on both sides. For example, a symmetric laminate would be 0, plus 45, negative 45, negative 45, plus 45, and 0 degree. Unidirectional symmetry laminates. Unidirectional carbon fiber fabric is the non-woven carbon fiber fabric with an edge fiber following in a single parallel direction. This sort of cloth has no space between strands and the fiber lay evenly. There seems to be no cross-section width that cut the fiber strand in half in the opposite direction. This allowed for a larger concentration of fiber, which gives the cloth more longitudinal tensile strength than any other wave. Quasi-isotropic laminates. When the individual lamina are aligned in such way that they generate an isotropic A matrix, the result is a quasi-isotropic laminate. For quasi-isotropic laminate, there are few principles to follow. There must be a total of n more than 3 layers. The same must be applied to all orthotropic elastic constant and thickness. They must be made of the same material. Mechanical property. First is strength. The capacity of material to without falling to withstand a load of plastic deformation is referred to as strength in a material mechanics. Elasticity. Elasticity refers to a material capacity to remove to its original shape after being stressed. Plasticity. Plasticity is a mechanical characteristic of materials that illustrate their capacity to distort without bending beneath strain and to maintain the distort once the burden has been lifted in form. Hardness. Hardness level over a certain threshold reflects a material capacity to sustain localized strength. Toughness. Toughness is a mix of strength and plasticity. A tough material is one that can sustain several impacts without cracking. Brittleness. The attribute of brittleness is the polar opposite of plasticity. Stiffness. The stiffness of a component refers to how it bends under stress while maintaining its initial form once the force is removed. Ductility. Ductility is a material capacity to endure plastic deformation until breaking and is quite comparable to plasticity. Malleability. Malleability is similar equivalent to definition. It does, however, accurately represent a material ability to resist comprehensive deformation. Cohesion. The cohesion force keeps things together and keep them from breaking apart. Impact strength. The amount of energy that a material can withstand when a force is impacted abruptly to it is called impact strength, also known to impact toughness. Fatigue. Fatigue is defined as the beginning and spread the fracture in the material because of cyclic stress in material science. Creep. Creep, also known as cold flow, is just the propensity of a solid material to distort slowly or permanently under the impact of steady mechanical stress in material science. Now we move to methodology. Discuss a variety of data collection and processing methodologies. Flowchart of the research. The sequence of procedure to complete the research is depicted in this diagram. We start with problem identification, define the objective, literature review, and then we proceed to parameter and procedure, determine the dimension of the material, develop the model and material in ASYS, import the geometric model, assign the constraint of the model, perform a simulation, and record the result. If we will modify the model if necessary, compare the perform analysis, conclusion, and that's all. In this project, we will be using epoxy carbon woven 230 GPa prepack. The woven process was done by using Excel composite paper software. The length is 100 mm, width 10 mm, and thickness is 0.29 mm per ply laminates. Determine the mechanical property of each laminate. First is finite element method. The finite element technique is a numerical approach for addressing problems involving partial differential equations or challenges involving functional reduction. A domain of interest is a collection of finite components, infinite elements. Approximation features are expressed as follows: of node point of a desired properties field, a fractional order finite element problem, or with a certain order value is created from continuously physical issue. The sequence of linear algebraic equations should be solved to solve linear problem. Second is flexural. Flexural test is commonly used to assess flexural strength and flexural modulus. The greatest strength of the outermost fiber on either the compression or tension side of the specimen is termed as flexural strength. The flexural modulus is calculated using the gradient of stress versus strain deflection curve. Third, 3-point bending. An electronic universal tester equipment was used to perform the 3 bending test. Balance and quasi-isotropic stacking sequence laminate were tested first, and then unidirectional. Each test specimen was given a load displacement plot, and every type of composite laminate was evaluated 3 times. Next is boundary condition. The boundary condition of a mathematical equation are an essential component. They have complete control over the flow of data, leading in an one-of-a-kind answer. Researchers are familiar with basic boundary conditions such as inlet, outlet, wall, symmetry, and so on in any composite purpose, or in general in any CFD program. Here is my project preliminary result. First is balance symmetry laminate. We have the deformation of 6.662 E negative 004. Unidirectional symmetry laminate, which we get 5.2998 E negative 004. And quasi-hydrotropic laminate, we get 6.5993 E negative 004. Last but not least, conclusion. The data will be collected from FEM simulation and calculation. Extrapolation of data method will allow researchers to determine the material mechanical properties.